Use the sample data and confidence level given below to complete parts A through D. In a study of cell phone use in brain hemispheric dominance, an internet survey was emailed to 2,561 subjects randomly selected from an online group involved with ears. 1,022 surveys were returned. Construct a 95% confidence interval for the proportion of returned surveys. First part is we want to be able to find the best point estimate of the population proportion P, and we're going to round to 3 decimal places as needed. So, first thing we need to know is what is the sample size. So the sample size was emailed to 2,561. So N is going to equal 2,561. Now X is going to represent the number of surveys that were returned, which is the number of successes, which is 1,022. So now we want to be able to find the point estimate. To find the point estimate, it's going to be the value of X divided by N. So we have 1,022. Divide that by 2,561. And we're going to round that to 3 decimal places. So we take 1,022 divided by 2,561. And we're going to round it to 3 decimal places, which gives us 0.399. So let's go ahead and substitute that into our answer and check. Therefore, there is the best point estimate. Now we need to identify the value of the margin of error. So to identify the margin of error, we have to use the following formula, where we have the Z critical value, the point estimate, the complement of the point estimate, and the value of N, which is the sample size. Well, we know the value of N, which is 2,561. We just determined that the point estimate is 0.399. To find the complement, we're going to take 1 and then subtract 0.399. So let's go ahead and do that. 1 minus 0.399 gives us 0.601. And now the next thing we need to do is find the critical value. So the first thing we need to do is determine, okay, well, we know that our confidence level is 95%. So in order to find alpha, it's going to be 1 minus that 95%. And that's 1 minus 0.95, which gives us 0.05. Then we're going to take alpha and then divide that by 2. So 0.05 divided by 2 is going to give us 0.025. Now remember that this represents the critical value, where the area is to the right, represents 0.025. So if we would draw our bell curve, knowing that we have our mean of 0, well, this is going to represent our critical value that has an area to the right of 0.025. So the area is 0.025. We're going to go ahead and shade that. And so in order to find that critical value, we want to find the probability of what Z value is going to give us an area of 0.025. So let's go ahead and do that using StatCrunch. So we're going to open up StatCrunch. Then we're going to go to Stat, select Calculators, and then go to Normal. Okay, so we want to make sure that we have the mean of 0, standard deviation of 1. We want to make sure that we're selecting the greater than or equal to because it's shading to the right. And then we want to put in the area that's shaded, which is 0.0250 in this case. And that's going to give us 1.96 rounded to 2 decimal places. So that's going to be our critical value. And now we can use that into our formula to find the margin of error. So let's go ahead and do that. So we're going to take 1.96, which represents the critical z value, and then we're going to take 0.399, which is the point estimate, times the complement of the point estimate, and then divide that by the value of the sample size, which is 2561. And then we're going to round that to 3 decimal places. So let's go ahead and do that. So inside the radical, we have 0.399 times 0.601. And then we're going to divide that by the sample size of 2561. And now we're going to take the square root of that result. So the second square root of that answer. And then we're going to take that answer and multiply it by the critical value of 1.96. So times 1.96. And we're going to round that to 3 decimal places, which gives us 0.019. So let's go ahead and check that answer. So the margin of error, 0.019, and there's our result. Okay, now what we want to do is construct the confidence interval. Now, before we construct the confidence interval, we need to check the requirements to construct a confidence interval used to estimate a population proportion. So we know that the sample is a simple random sample. We know that the conditions for the binomial distribution are satisfied, and there are at least 5 successes and at least 5 failures. Okay, so now we can go ahead and then use the interval. So we know that the point estimate that we found in part A is 0.399, and then we found the margin of error in part B to be 0.019. So we're going to take the point estimate of 0.399 and then subtract the margin of error of 0.19. And on the right side, we're going to take the point estimate and then add the margin of error. So if we take 0.399 and then subtract 0.019, we get 0.380 for the lower limit. On the right side, 0.399 plus the margin of error of 0.019 gives us 0.418. So let's go ahead and put our value in for our confidence interval. So the lower limit is 0.380, and then we determined that the upper limit is 0.418. Checking our answer, and then we get our result. Now we need to write the statement that correctly interprets the confidence interval and then choose the correct answer below. So what we want to do is we know that we want to say that the 95% confidence interval means that 95% of that interval is going to contain the value in between the confidence upper and lower limits. So we would say that one has 95% confidence that the interval from the lower bound to the upper bound actually does contain the true value of the population proportion. So that would mean that it would be D. And there is our result.